All right, welcome back everyone. We are going to have 6.2 geometric sequences, and this is going to be the shortest video that I'll probably ever make, okay? Now, our learning goal is, you guessed it, to write the explicit rule for geometric sequences. Notice how there is nothing about a finite sum here or an infinite sum. That is going to be much more 6.3, okay? So this is more of an Algebra 1 standard to prepare you for the series, okay? Now, to review again, just in case you kind of missed this concept last time, a sequence is an ordered list of numbers, okay? And we have two sequences here, right? We have this sequence and have this sequence. And when we did it in the last one, we talked about this difference, and it was a plus 2, plus 2, plus 2, plus 2, right? And we called this the common difference, okay? And that terminology is important. When you have a common difference, it is because of adding and subtracting, okay? And then, you know, in that last video, we kind of brushed over this one, all right? This one is a geometric sequence, which is basically the same exact thing, except for instead of addition and subtraction, it's from multiplication. Notice how I did not say multiplication and division. I just said only multiplication, okay? So we have a difference, but we no longer call it a difference. We call this one a common ratio, okay? And so we have, and oh, let's actually do this again. This one's defined as R, or so sorry, this one's defined as D, and this one's defined as R when you see it as a variable, okay? So here, 3, negative 9, 27, negative 81, we're multiplying by negative 3. We're multiplying by negative 3, okay? All the way through, all right? So it is multiplication. Now, what if you're going down? What if I have, let's go 10, 5, 5 over 2, right? This gives the appearance that to go from 10 to 5, I divided by 2. But that's not true. You multiplied by 1/2, okay? And when you multiply by 1/2, it gives the appearance of division because you are eventually going to divide, right? 10 times 1/2, 10 times 1 is 10, and then it's 10 divided by 2, okay? But we do not use divided by 2 for our common ratio because you're going to see with the formula we need it to be multiplication, even if later it turns into division. Okay, much more than I wanted to introduce on this page, but that's okay. So here's our explicit rule for geometric sequences, okay? And it's very, very similar to the other one. Notice how instead of a plus, right, we have multiplication here, right? And instead of, doing an n minus 1 being multiplied with our common ratio, we're taking our common difference, we're taking our common ratio to the power of n minus 1 now, okay? And also, if you hear maracas in the background, that is just my children playing with music toys. It was quiet for the last hour, thought it was going to be good to record, and now there's the xylophone, okay? So hopefully you're enjoying, if you can hear it, hopefully you're enjoying the soundtrack to these notes, okay? All right, so let's break this down. We still have first term, okay? Now we have common ratio. We still have notation. And we still have the, nth term, right? The term that we're looking for. So things are really just organized differently, and that's about it, okay? All right, let's do a couple, okay? So first thing you always want to do is you want to identify, what type of sequence it is. Here we see we went from 150 to 30, from 30 to 6, from 6 to 1.2. Now, here's a trick, okay? Here's a trick to kind of figure this out. If you go, gosh, what did I multiply to go from 150 to 30? Maybe you could think about that off the bat. Maybe you can't. Pick a number, preferably one of the smaller numbers. Pick a number, a term, and divide it by its previous term, okay? And you'll have the common ratio. So I'm going to take 6, and I'm going to divide it by the previous term, which is 30, And if I simplify that, 6 over 30 is going to simplify to 1 over 5. And that happens to be what I'm multiplying. Okay, and if I did this with 30 and 150, again, 30 goes into 30 one time, 30 goes into 150 5 times, so I get 1 over 5. My common ratio is 1 over 5. Okay, nice and easy. All right, we have our first term, so we have everything we need to build the explicit rule. A of n is equal to 150 multiplied by 1/5 to the power of n minus 1. Okay, so first term, common ratio to the power of n minus 1. Now, okay, there is, unlike the arithmetic sequence, right? In the arithmetic sequence, you had to simplify after, and this one, that's the most simple form. Okay. Sorry, I just hear the music. It's so hard to focus right now. All right, let's find the 8th term. So we got a of 8 equals 150 times 1/5 to the power of 8 minus 1, which is really just going to be 7. All right. Now, of course, you could figure this out. You could do 1 to the power of 7 and 5 to the power of 7. I'm not going to do that. I'm just going to use my calculator, so I know you won't be able to see this. Still figuring out how to get a calculator on the screen easily. But we got 0.2, so 1/5 is 0.2, and I'm going to take that to the power of 7. So give me a second here. To the power of 7. And you get a ridiculously long number of 0.0000128. And then you're going to times that by 150. And then answer, the 8th term, should be 0.00192. Okay. All right. Let's quickly recap here. All right. You have a sequence. Identify what type of sequence it is first. Because on a test, you're going to get arithmetic and geometric and potentially a different type that you would do nothing with thrown into the same problem or into the same exam. So make sure you identify the pattern. If you see multiplication, all right, you can use this trick. Pick a term and go back and divide it, and you get the common ratio. Okay, because remember, division is the opposite order of multiplication. So if I'm going this way to the right and I'm multiplying, then going to the left is dividing. So I'm just leveraging that. Okay, we built our explicit rule, and then we plugged in to find the term. Okay, now here is one for you to do. See if you can find that common ratio and find the 8th term. Good luck, give it a try, and then I'll go over it. Okay, so hopefully you gave it a try. You have your first term here is -7. Oh, almost made a mistake. And then we need to find our common ratio, okay? Now again, here we can pick a number. We could do that also, right? I could, I want to pick the smaller number, so I might pick 35 and divide it by -7. That's a good way. And sometimes you can just look and see. So I kind of think to myself, 7 times 5 is 35. 35 times 5 is 175. We are jumping back between positive and negatives, and so my common ratio has to be negative. Okay, now again, you could have done the 35 divided by -7 to get -5 also. All right, so let's build our rule. We have a of n is equal to the first term times the common ratio to the power of n minus 1. Boom, done. And then we plug in the 8. A of n is equal to -7 times -5 times 8 minus 1. Right, so -7 times -5 to the power of 7. So I'm going to take my calculator. 5 to the power of 7 is a very large number, okay? Now, in my calculator, I just did +5 to 7, and I see that I'm multiplying an odd amount of time, so I know it's negative, but you probably want to make sure you plug in the negative there too before you take it to the power of 7, okay? So you get -78,125, so -7 times -78,125, and I multiply that by -7, which would bring me to a positive 546,875. Boom. Okay, that's the 8th term in the sequence. All right. Now, yep, that's the end. Okay, shortest video I've ever made. probably because it's so short, deserves a like, subscribe, and a comment. And I'll learn how to connect with my community in time. Okay. See you guys next time. Adios.